Next example. A duathlon has a racing and biking component. So the entire race was 6,000 meters. And on average, people run at 3 meters per second and bike at 8 meters per second. If a racer completed the entire race in 1,125 seconds, how long was she biking? So pause the video and write this down. We're going to be moving on. So we need to come up with two variables. So what I might go for is I might say that A is time biked and B is time she ran. Now the equations are not, before we do the equations, we have to remember something briefly. So what we're going to have is we're going to say that speed equals distance over time. And we can rearrange that to say that distance equals speed times time. And we could say that time equals distance over speed. So keeping that in mind, we're going to make another one of those tables. So this is going to be distance, this is going to be speed, and this is going to be time. And here we're going to have biking and running. Let's see what we know. So we know that people bike at 8 meters per second. So that's 8 meters per second. And they run at 3 meters per second. And that's kind of fixed. Now the time biked is going to be A, because I defined it like that. And the time that we ran is going to be B, again, because we defined that by like that. So we can calculate this. The distance is, and we go to our formula here, distance is speed times time. Speed times time. So the distance is going to be 8A, which is, so A seconds, and it's 8 meters per second. And this would be 3B. And we could kind of put a total here. So the total distance is 6,000 meters. And the total time is 1,125 seconds. And from this, we can now make our equations. So our two equations are going to be A plus the time plus the time is the total time. A plus B equals 1125. And the two distance ones are going to be 8A plus 3B equals 6,000. Now, I'd like to point out, I was a little vague in this question, like how long was she biking? Is that how long distance or how long time? And we're going to see why. It turns out, I'll try to be more specific. Well, obviously when it comes out to a test, but I want to show it both ways. That would be our two equations, and that's what we could solve. Now what we could have also done instead, though, is we could have defined the variables differently. Instead of time biked, it could be, A could be distance biked. And B could be distance run. Distance she ran. Distance run. I don't know. Either way. So now we're going to make our table again, but it's going to be different this time, because what we've done is we've changed the definition of the variables, which is why it's really important when you're defining the variables. If you just said the variable was bike and run, do you mean distance or do you mean time? And it's going to make a difference. So you have to be pretty specific. So distance, speed, time, bike, run. So the speed, nothing's changed there. That's 8 and 3. And our totals are actually the same as well, right? So the total distance is still 6,000 and the total time is still 1,125. What's changed here is that the variables have changed. So now instead of time being A and B, the distance is going to be A and B. Now we're going to have to figure out the formula. So the formula for time is distance over speed. So the time is going to be the distance divided by the speed. So it's A over 8 and B over 3. Putting that together, we get for our two equations that A plus B is 6,000 and A over 8 plus B over 3 equals 1125. What does that do? Well, we're going to get different answers. So we have two different sets of equations, and we're going to get different answers for an A and B, but that's because A and B don't represent the same thing here. Here we defined A as time and B as time, and here we're defining them as distance. So it's important that you figure out what you're defining it as, and then do it appropriately. Next question. So a boat chugs upstream and then goes downstream. The one-way trip is 48 kilometers, and the boat took 6 hours to make the trip upstream, but only 4 hours going downstream. How fast is the boat? How fast is the current? You could pause it, write it down. So just a quick demo. Let's say you have a boat, and it moves at 7 kilometers an hour. And then the water moves at 2 kilometers an hour. So when you're going downstream, when you're going with the water, when you're going downstream, the actual speed is going to be 7 plus 2, which is going to be 9. If you're going upstream, of course now you're going against the water, it's going to be 7 minus 2, which is 5 kilometers an hour. So that's what's going on here. We have a boat going downstream, we have a boat going upstream, and we're going to have different times. So the variables, and the question kind of gave them to us. It's going to be how fast is the boat? So A is going to be speed of boat, and B is going to be speed of current. So we're going to make one of those tables again. So distance, speed, time, upstream, that means against the current, and downstream. And we're going to have to figure some things out. This one's going to be different than the last question. It's another distance, speed, time one, but it's not quite the same. So, going upstream, so the distance of the trip is 40 kilometers. So in this case, the distance for both of them is 48. They're both 48 kilometers. Now the time, when we were going upstream, it took 6 hours. When we were going downstream, it took 4 hours. That's from the question as well. Now speed is going to be a little bit different. So speed, when we're going with the current, so downstream is we're going with the current, it's going to be the speed of the boat plus the speed of the current. So the speed here is going to be the speed of the boat plus the speed of the current. When we're going upstream, it's going to be the speed of the boat minus the speed of the current. And now we're going to go back to the formula, which I have moved, unfortunately. So that's going to be, but the formula is that speed equals distance over time. And so we can actually go right to our two equations. And the two equations are, so for upstream, the speed, which is a minus b, equals the distance over the time, equals the distance over the time. And the other equation is going downstream, the speed is the distance over the time. Or if I wanted to write it in a slightly prettier way, I would say a minus b equals, and 48 divided by 6 is 8, and a plus b is 12. And those would be two equations, and that would be really nicely set up for elimination. And that's it.